Yeah. Shailaja, you tell me that what is the electronic configuration of chromium we had written. Chromium. Chromium has got the atomic number 24. 24. What is the electronic configuration you had written of chromium? Just tell me. Tell me. Unmute yourself and tell me. Yes? Yes? I'm waiting for you. Shailaja, I asked. Please tell me. 1 is 2. Shailaja, unmute yourself. Yeah. 2 is 2. 2p. 2p6. 3s2. 3p6. 4s2. 3d4. Okay, so 24 electrons. So we just arrange the 24 electrons according to the energy level, and this is the electronic configuration. If all of you have written it, fine. I don't have any problem. If all of you have written it, I don't have any problem. Those who have tried, I hope everybody has written it down. But in our syllabus, there are 2 atoms who has got exceptional electronic configuration. This is one chromium and another one is copper. Somebody else, whoever has told, I don't know, I couldn't see who has told it. Somebody else now tell it for copper. Somebody else is tell it for copper, which has got the atomic number 29. Somebody else. Yeah, it's Smriti Agarwal. I can see you. Yeah, you tell me. What is the electronic configuration of copper you had written? Tell me. Electronic configuration of copper, what you have written? Tell me. Smriti Agarwal, you just unmute yourself and tell me. Yes. Some problem? Who else want to say? Srishti, are you there? Srishti, are you there? Srishti Chatterjee, are you there? No. Surprising. Niden, are you there? Niden, are you there? No. Trying to unmute the mic, but I am facing issues. Okay, fine. That is Srishti. Then Niden is there? No. Niden Lamu, are you there? Whichever name I can see, I am just asking them because we didn't meet ever. You have seen me, but I never had saw you. Rahmat, are you there? Okay, fine. Rahmat, are you there? No. Angesh, but nobody could unmute yourself. Okay. Calvin. No. I don't know whether you have done it or not. Gaurav Agarwal. I know your network is working. What happened? Did somebody tell them? No one is telling. This is very sad. Yeah? Who is this? Who is this? Okay, tell me. Tell me.
So AR plus
No, tell from the first. 1s2 onwards, you just tell.
1s2,
1s2,
2s2,
2s2,
2p6,
2p6,
uh, 3s2,
3s2,
3p6,
3p6.
3d5,
No, after 3p what comes?
the 4s2,
Yeah, 4s2,
then 3d5.
3d5 by total 29 are there.
So it will take half of the total electrons.
What?
It can take.
Total 29 are there. Total 29 are there, copper.
3d5 plus 4p2.
No, who taught you this? I never told you this. No, I never told you this. I just told you just fill up the electrons according to their energy levels. So 3D maximum 10 electrons can go, right? 3D maximum 10 electrons can go, and you had already filled up how many? 2, 2, 4 and 6, 10, 10 and 2, 12, 12 and 6, 18, 18 and 2, 20, 20 already you had filled up. So 9 more is there. So if 9 more is there, so obviously that should go over here in 3D 9. Huh? Why you are going ahead and going ahead with a wrong concept? Please don't do that. Please don't do that. Okay? That's the problem in Shiliguri, let me just tell you, okay? If you are in Shiliguri, that's the problem in Shiliguri. There are so many people who are going much ahead, but going ahead with the wrong concept. Okay? So please don't do that. Okay? So chromium is this, copper is this, whatever I told, but these two has got the exceptional electronic configuration. What is the actual electronic configuration of chromium? One of the electron from 4s orbital, one of the electron from 4s orbital jumps to 3d orbital. Okay, one of the electron from 4s orbital jumps to 3d orbital. So actual electronic up to here it's same, up to here it's same. Then it is 4s1, 3d5. Why? I will come to that. So if somebody tells you to write down the electronic configuration of chromium, you are going to write it as 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. Why? I will come to that. Again I am saying why I will come to that. You must know the concept. Okay? Exactly similar in case of copper also. As I told, there are so many elements which has got the electronic configuration. But in your syllabus only 2 are there. So these 2 you must know, and you must know the reason. Same way copper may be what happens. So one of the electron from 4s jumps to 3d. So actually it is expected to be 4s to 3d9 according to the rule n plus L rule. But it is found, or it is actually 4s1 and 3d10. 4s1 and 3d10. One electron from 4s jumps. So 4s becomes 1 and 3d becomes 10. Now why this is happening? This electronic configuration, the actual electronic configuration, gives some extra stability. How it gives extra stability and why it is jumping? 2 questions. It is jumping because, first one, why it is jumping? It is jumping because the 4s orbital and the 3d orbital has got almost the same energy. 4s orbital and 3d orbitals has got almost the same energy. So it will be easier for the electron to jump from 4s to 3d. Now why it will jump? It is jumping because of that. It is not jumping from 4s to somebody else, somewhere else, or somewhere behind. No, behind, so there is no space. Somewhere in front also it could have jumped. Okay, but it is not jumping. It is jumping only to 3d. Why? Because they are having the energies almost same, so they won't face any difficulties in jumping from 4s to 3d. Yes. Now why are they jumping? How they are getting the extra stability? They are getting some extra stability by going to 3d. How they are getting the extra stability? Now you will understand this. Okay, suppose I am talking of the chromium. So I'm just drawing the electronic configuration in the box form. This is 4s expected one. First I'm drawing expected one. 4s2 and 3d4. I think all of you have done it. 1, 2, 3, 4, 5. So 3d4 is 1, 2, 3 and 4. This is 4s2, 3d4. Yes, 4s2, 3d4. This is expected one. Expected one. Okay, fine. But what is the actual one? So what is there? What can you see? In one orbital there are 2 electrons. In 4 orbitals there are 1, 1, 1, 1 electrons of d, and one orbital is vacant. One orbital is vacant. Okay, this is the condition of it. Now, what is actual configuration? Actual configuration is 4s1 and 3d5. 4s1 and 3d5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3d5. 4s1 and 3d5. Now forget about 4s. S, there is only one orbital, so we are not worried about that. We are more worried about the d orbital. More worried about the d orbitals. There are 5 d orbitals, and all these 5 d orbitals I told degenerated. Degenerated. Degenerated means they are having the same energy. They are having the same energy. Now I already mentioned that this particular electronic configuration, when d orbital has got 5 electrons, is more stable than that of d orbital having 4 electrons. That is why the electron is jumping. Okay, why is it so? Because of 2 reasons. Simply because of 2 reasons. The first reason is symmetry. The first reason is symmetry. You see, out of these 2 electronic configurations, which is more symmetrical? There are 5 rooms in a hotel. Similar facility, 5 rooms. Okay. In 5 rooms, 4 people are staying and 1 is vacant. Is that symmetric? Or in 5 rooms, 1 people are staying. Is that symmetric? Obviously, this is symmetric. More the symmetry, more is the stability. Okay, so out of these 2 electronic configuration D4 and D5, D5 is more stable because of symmetry. That is first thing. Okay, for which it is imparting the extra stability. It is imparting the extra stability. The second thing is exchange energy. The second thing is exchange energy. Okay, what is exchange energy? Please understand it. What is exchange energy? All of you understand the term exchange. Exchange means I am going to give you something, you are going to give me something. That is exchange. Okay, it's not giving or it's not taking, it's exchanging. Okay, I will give you and you will give me back. Okay, exactly the same over here. I told these 5 rooms are exactly having the same facilities. Now they can exchange among themselves the rooms. Exchange, remember the word exchange. Exchange among themselves in the rooms means this electron can exchange with this. It can go here, this can come here. This electron can exchange with this. This electron can exchange with this. So how many exchanges the first electron can do? The first electron can do 3 exchanges. 3 exchange. It cannot go to the empty. If it goes to the empty, nobody will come to his place. Okay. So exchange can be done to the rooms where already the electrons are there, to the orbitals where already the electrons are there. So the first electron can do 3 exchanges. Now the second electron can do an exchange with this, which we already counted with the first one. But second can do the exchange with this also. Second can do the exchange with this also. That means 2 more new exchanges can be done by the second electron. So first electron can do 3 exchanges. Second electron can do 2 more exchanges, 2 more new exchanges. Now let us see about the third one. Third one can do the exchange with this, which we already counted. Third one can do the exchange with this, which is already counted. Now a new exchange third one can do is with the fourth one. So that is 1 more exchange, 1 more new exchange the third one can do. Now if I take about the fourth one can do the exchange with this, already counted. Fourth one can do the exchange with this, already counted. Fourth one can do the exchange with this, already counted. Right? So the total number of exchanges that is possible, why are they exchanging, I already told you. Total number of exchanges that is possible if 3D में 4 electron है तो, if there are 4 electrons in 3D orbitals, the total number of exchanges that is possible is 6, right? Only 6. 6 exchanges are possible. But if there are 5 electrons now in 3D orbital, 5 electrons are there in the 3D orbital, how many exchanges are possible? Let us see. This can exchange with this, this can exchange with this, this can exchange with this, this can exchange with this. So the first one can do 4 exchanges, right? Second one can do the exchange with this, which we already counted. New exchanges it can do 1, 2 and 3. Hope you understood that. Third one can do the exchange with this, which we already counted. Third one can do the exchange with this, the first one, which we already counted. New exchanges it can do with fourth one and fifth one. So 2 more. Now fourth one can do the exchange with this, counted. Fourth one can do the exchange with this, counted. Fourth one can do the exchange with this, counted. Fourth one can do a new exchange with this, okay, with the fifth. Fifth ones, all exchanges are already counted. Fifth ones, all exchanges are already counted. So what is the total number of exchanges? You see 4 plus 3, 7 and 2, 9 and 1, 10. 10 exchanges are possible. In the first case, there were 6 exchanges possible. Now in the second case, 10 exchanges are possible. More the number of exchanges, more is the stability. I know somebody gave me the answer, okay. He was told, I know, that just to mug up, that half-filled and full-filled d orbitals are more stable. That is not a concept. That is, finally we are coming into that. What is half-filled? Now, I will come to that now, okay. So half-filled means total number of electrons that can go in a d orbital. Total number of electrons that can go in a d orbital is 10, right? If it is half-filled, there will be 5 electrons. If there are 5 electrons in the d orbital, it is more stable. Why that is more stable? Because it is symmetric, number 1. Number 2, it has got more exchange energy. Clear? Okay. And hence the half-filled d orbital or half-filled degenerated orbital in normal sense we can say degenerated orbital. Degenerated orbital means it can be p orbitals 3, it can be f orbitals 7. Half-filled degenerated orbitals are extra stable. Extra stable. Why extra stable? This is just because of 2 reasons. What are the 2 reasons? Number 1, symmetry, and number 2, the exchange energy. Number 1, symmetry, and number 2, the exchange energy. Because of this, the half-filled d orbitals or half-filled degenerated orbitals are more stable. Exactly the same is applicable for the full-filled degenerated orbital. Full-filled degenerated orbital means if the degenerated orbitals are fully filled, then also their symmetry, all of you can understand that symmetry, every room there are 2 electrons, symmetry and exchange energy. Obviously the number of exchanges will be maximum in that particular case, will be more, exchange energy will be higher, and they are stable. And that is why these 2 elements, chromium and copper, are showing the electronic configuration which is little different from the rule. That is why we call them exceptional electronic configuration. And one more thing I told you, you should remember that why the electron is jumping from 4s to 3d. The electron is jumping from 4s to 3d just because the energy level of 4s and 3d are almost same. Obviously they are not same, not exactly same, but they are almost same, so they can jump from one to the other. Okay, now you do it for if somebody tell me that what you do it for titanium. Titanium, the electronic configuration is, as far as I can remember, it is 22. Is it 22 titanium?
Yes, sir.
Yes. Tell me the electronic configuration of titanium. Tell me the electronic configuration of titanium.
So it's 1s2,
Yes, 1s2,
2s2,
2s2,
2p6,
2p6,
3s2,
3s2,
3p6,
3p6,
4s2,
4s2,
3d2.
3d2. Fine. Okay. Now you know every orbital, whatever we wrote individually by some way, by some representation, 1s, 2s, 2p. Everything's meaning you know because we explained it in detail, the quantum numbers. So 2p, if I talk about 2p, what do you know? That we are talking of second shell, that is the value of n is equal to 2. We are talking of p orbitals, that is the value of L is equal to 1. We know everything over here. Okay. So we know shell, we know orbital, we know exactly which orbit is there. We know everything. We know the nature of the electron, plus up, minus up, whatever, everything we know. Okay. And if I tell you to write down the box form also, you can write it down. Now I am asking you to write down the electronic configuration for titanium 2 plus. Titanium 2 plus. How? First of all, you tell me how titanium 2 plus is formed. How titanium 2 plus is formed? Titanium 2 plus is formed by losing 2 electrons, right? By losing anything positive. How the positive charge is formed? By the loss of electron. 2 positive means 2 electrons will be lost. Will anybody tell me what is the electronic configuration of titanium 2 plus? How many? First you tell me how many electrons are there in titanium 2 plus. First you tell me how many electrons are there in titanium 2 plus. Titanium there are 22 electrons. Okay, titanium 2 plus, how many electrons are there? Tell me. Titanium 22 electrons, so titanium 2 plus, how many electrons will be there? Yes, it's very simple question I asked. Yes? 20. Okay, fine. Fine, that's absolutely correct. Because titanium 2 plus will be formed by the loss of 2 electrons simply, nothing else. Okay? 2 electrons will be lost and titanium 2 plus will be produced. Now tell me the electronic configuration of this ion. What we are doing now, till now we have done the electronic configuration for the atoms, neutral atoms. Okay? Now we must understand how to write down the electronic configuration for the ionic species, for the ions. Okay? Now somebody tell me what will be the electronic configuration for this ion. For this ion. Tell me.
So 1s2,
Okay, 1s2. I am accepting it.
2s2,
2s2,
2p6,
2p6, yes.
3s2,
3s2,
3p6,
3p6,
4s2.
4s2. Bas done. Okay. I think all of you, if not all, at least 90% of you will write down like this. Okay, 90%, if not more than that. If not more than that, 90% of you will write down this. But this is absolutely wrong. Okay, because I didn't teach you, that is why you told it wrong. You know 20 electrons, you filled up 20 electrons, fine. But now I am coming to the concept. See, if you know the concept, you can do it very easily. Now I am coming to the concept. A neutral atom is becoming a positive charge. Fine. How it is becoming a positive charge? Just you know it. It's not that you don't know it. It is becoming a positive charge. How it is becoming a positive charge? It is becoming a positive charge by losing electron. If it loses 1 electron, it will become plus 1. If it loses 2 electron, it will become plus 2 and so on. Plus 3. Okay, till plus 3 generally it happens. Okay. Very few are there plus 4. Okay, so plus 3 or plus 4. Okay, fine. So number of electrons lost we know. Now the question is that, whose answer you all of you know. Tell me from where the electron will be lost. Tell me. From where the electron will be lost. Which electron will go off?
So the valence electron.
The last shell electron or the valence electron, right? It's the last shell electron or the valence electron that will go off, right? You know it, see? All of you know it. valence electron or the last shell electron will go off. Now tell me over here, you had written down the electronic configuration of titanium. Tell me what are the shells present here. First shell, second shell, third shell, here also third shell. But this is what? This is fourth shell, right? So what is the last shell? What is the last shell? First or second or third or fourth? Fourth shell. So from where the electrons will go? The electrons will go from the fourth shell, right? The electrons will go from the fourth shell, because the valence shell, just now you told, all of you know this, valence shell loses the electron, and valence shell means the last shell, that all of you know this. So 2 electrons will be lost. So 2 electrons will be lost from where? 2 electrons will be lost from the fourth shell. Okay, here the fourth shell is there. Though we wrote 3D afterwards, that does not mean that 3D is the last shell. Last shell is fourth shell. So the valence electron will go from fourth shell. So 2 electrons, if it goes from fourth shell, it will become 4s0. 4s0 and 3D, the electrons will remain as such. 3d2, that will be the electronic configuration of titanium 2+. Did you understand that? Is it clear to you? If it is clear to you, then you write down the electronic configuration for titanium 3+. Titanium 3+. And somebody tell me, titanium 3+, what will be the electronic configuration? Yes, I'm waiting. If anyone to answer.
Can you repeat the question, sir?
What is the electronic configuration for titanium 3+? Titanium 3+. 3+ means what? 3 electrons are going off. 3 electrons are going off. So what is the electronic configuration for titanium 3+? Then we are today actually studying what? Actually we are studying the electronic configuration for the ions, and we know just one concept. The ions are formed by the removal of electrons from the which shell? From the valence shell or from the last shell. Okay, fine. Tell me now the electronic configuration of titanium 3+.